I convinced you that these are exciting times to be in this business. So I want to share with you, let's see, I started in the industry in '74. I took a lecture in 1981, way before you folks were born, I guess, but Carver Mead, or Carlos Aiken was the lecturer using the Carver Mead methodology, and he presented a lecture that said at that time, it was way early on in the industry, he was saying that the designer has to, as the industry was going to progress, needed to broaden the horizon. So if you were a features person, like a lithography engineer or a ion implant engineer, you kind of needed to know about devices. If you were in the 60s then, if you're a features engineer or devices and gates, you needed to move up this chain as well as broaden yourself. That was the fundamental theme of the message. And here's a hierarchy. So there's features that you build devices with that, you build gates with those, registers, bit slices, processors, computers, and systems. So that's the hierarchy of a device that needs to be built. And the fundamental message is you've got to move up the chain and broaden yourself. So this is 1981, right? So that's how many years ago? Almost 40 years ago, right? I think that's still true. In fact, I was able to dig this out from my archive. So instead of being a short, fat designer, in other words, be focused only on one area, you want to make yourself a tall, thin designer. So whoever asked the question in analog design, keep that in mind. So you could redo this chart. Analog could be one piece of it, and you got to be good at it. And you can continue to be the short, fat analog designer for the rest of your career. And there are people like that. There's nothing wrong with that. But if you want to open up more opportunities, I would suggest become the tall, thin designer. Understand the system, understand digital, understand the application, understand what value you can bring, and that will open up all kinds of opportunities for you. If I were to start over, that's what I would do. Go into an area that broadens my horizon. And again, I mean, you'll see by the end my commitment to entrepreneurship and what it takes to be a good entrepreneur. You're always looking for ideas and looking for applications of what is a customer problem. If you can help solve the problem and you can create a product that actually solves that problem, you've got a really good chance to be successful. Doesn't mean that you will, but you've got a good shot at it. Okay, so clear on this? Aim to be a tall, thin designer rather than a short, fat. Nobody's asking questions, so you're probably going to zip right by. Okay, the other thing I wanted to tell you is that if you look at where the industry is going, it's a crazy industry. I've got a list here of startup companies that were acquired. And I also say at the bottom, companies like Amazon, Facebook, Google, I guess is a bad word in China, but if those are companies that are really hot. So if you were graduating today and you want to go work in the United States at companies, you're a design engineer, you're a process engineer. 5 years ago, you would not even think about applying to Amazon and Google and Apple, right? And Facebook. Today, they are the leaders. So the world has changed tremendously. Let me give you some examples. How to read this chart. Take Google, for instance, Nest Labs. How many of you have heard of Nest Labs? They're a startup company. They created these digital thermostats. Now, I don't know their history, so I don't know whether when they did the startup, whether their exit strategy was to get acquired, but they did get acquired. They did get acquired for $3.2 billion. And they probably had, $100 million startup investment. So it was a 32x multiple. You can go through all of these examples. Oculus, for instance, was acquired by a virtual reality company. The way to read this chart is that they were founded in 2012. They were founded in 2012. They were acquired in March of 2014, and total investment from startup investors was $90 million. They got acquired for $2 billion, 20 to 1 multiple. That is huge. So if you ask how Mark Zuckerberg became a billionaire at age 27, you can do it. You just have to be in the right place at the right time and position yourself correctly. I was being told yesterday, I guess there's a company called DeFi here in China. Bunch of young people, 7 or 8 young people, they're worth $1 billion. They're in the space of deep learning, artificial intelligence. So there's all kinds of opportunities, but you have to take the lead for yourself. And again, you'll have these charts so you can look at it. Here's WhatsApp, got acquired for $19 billion. So what I do warn my students is that not everybody's going to get there, but the opportunities are very much there. And so you constantly have to look at where you can make a difference. These companies are financial leaders. If you're interested in finances, I can point you to some references that if you look at their finances, the income statements, the earnings per share, revenue per employee, all of those things are just tremendously better than the likes of Intel and other traditional companies. So again, as you're trying to graduate and decide your career, I think these are kinds of things that you have to be aware of as you move forward. Other changes occurring in the industry. So what is happening? These people, in fact, let me go back here. What is happening here is that Google is trying to get Nest Labs integrated with their digital home, right? So the visionaries are trying to figure out how they can leverage the capability so that they can get into the home. Now, the Nest Labs founders know that. I don't know that particular company history, so I don't know, but they were pretty smart, right? They started off saying, oh, I got this analog circuit design capability, and let me create a thermostat that, or a digital technology, whatever they use, and the opportunity is for Apple iPhone or Google to integrate that into the phone so that the user can get a better look at what's the temperature in the home when they're traveling somewhere else. That's where the world is going, and you can play into that space if you're interested. So these are products that these companies have introduced, and they're getting more and more powerful. In order to make these work, you got to have voice recognition, you got to have processing capability. All of the inputs, like Professor Van der Spiegel is saying, are human interfaces are all analog. So you definitely need analog circuits and analog sensors and analog data processing. But the industry is also leveraging the digital processing capabilities, and therefore, you could be the best sensor designer or the sensor integrated circuit designer, but in order to ship a product that is an integrated sensor, you need to understand the digital part, you need to understand how to save energy, how to productize that in terms of a package, and how to be able to price it. So now you got these multiple disciplines that you have to be aware, and you really have the choice to decide whether you want to be the designer only, have somebody else do the productization. That's okay. That's kind of the overall theme of what I'm going to be telling you over and over and over. Another change that's happening, you take a company like General Electric. They are known to make dishwashers and aircraft engines and all kinds of big bulky items. They are wanting to get into, they want to become the Apple of the industrial internet. So they are making major investments in integrated circuits, in new product ideas for energy, jet engines, wind turbines, locomotives. It turns out they don't actually sell engines anymore. Totally different business model. They will lease the engines. And so again, the world is changing. That's the whole theme here. And if the old model was GE builds the engines and they ship the engine to somebody, that's no longer the business model. It's the business model where they'll make them, they'll lease them out, and every 3 years somebody buys a new engine. You know, so stay with the times, because involved in that very high level decision that GE made, it affects how the rest of the company operates, what kind of engineers they need, and how you can play into it. That's the theme of what I'm trying to tell you. So 4 years ago, that tells you when I was in Shenzhen, wasn't the last time, but I was riding the train. I don't speak the language, so I didn't have anybody to talk to. I looked around the metro, and I think 9 out of 10, whatever the number is, people were all looking at the phone at that time. This is 4 years ago. And that's when, you know, smartphones were the real heyday. They still are, but it's not as hot as it used to be, right? That was the time when they were really hot. And it's 5 billion plus worldwide. So, you know, today we all cannot live and survive without this device. But you people know what it takes to build these devices, but ask your siblings, ask your parents, ask your friends out there that are not in this field, do they have any idea what it takes to build this? Do they have any idea that you are involved in building this device as far as contributing the technology? We engineers are the absolute worst marketeers. I'm serious, this is terrible. This is very, very bad. This is something that IEEE worries about it too, right? I'll tell you the story. I'm United Airlines, I'm a frequent flyer, and that one program, I'm registered as Dr. Rakesh Kumar. So anytime I go to the counter and they realize I'm Dr. Rakesh Kumar, they hold me on a pedestal. Why? Because they think I'm a medical doctor. That's not the way to treat people that ought to have the respect, right? So I think it's our own fault. We don't advertise our capability, and so, you know, we can't live without this device, but we have no idea what it takes. So I always use this chart to do a one chart description of what it takes. It's a combination of software and hardware. Within that iPhone, there was one little strip. I think it was like 3 centimeters wide, 15 centimeters long, loaded with components on both sides. Somebody out there designs those, somebody out there builds them, somebody out there makes sure that it all works together. You know, in the old days when you were little kids, you probably had phones that had antennas that you had to pull up. There's no antenna. Where's the antenna in this thing? How does it receive the signal? How does it decide whether it's GSM or CDMA or whatever? Some engineer out there, whether it's Huawei or Qualcomm or MediaTek or whoever, is deciding what the characteristics of those chips are gotta be. Apple is integrating it and they're shipping the devices. Somebody's writing the apps for it. These things don't happen by magic. It happens because you and your predecessors in those fields make those things happen. So we have to do two things. One, feel good about this, that we're shaping the world. And number two, get the word out so that other people recognize and respect our profession. So on this printed circuit board, hopefully you've all seen one, is lots of components. These are active devices, discrete devices. Bottom of it all goes into a package, the chip itself, the silicon. The package has lots of connections. Anybody have an idea on a Qualcomm Snapdragon or an Intel processor? How many pins are there? Anybody know? It's over 1,000 pins. How does that happen? Magic? Does anybody know how much power gets dissipated in one of these things? Any idea? Take a guess. How much? 50?
CPU, just the Intel CPU,
Intel CPU is 10 watts. This thing, if it was 10 watts, it'd be so hot you'll drop it. There's no fan in there. 2 gigahertz operation. No more than 4 watts. Still gets very hot. Who designs those things? It is a tremendous challenge. I'm not saying this is harder to design than the Intel chip, but there is no fan. Managing the thermal conditions. So you could be the best analog designer, but if you can't manage the thermal dissipation, this device is not going to work. Tell me there's no challenge. It is just tremendous. So this is why I think this is such an exciting field. So let me just finish and then I'll come back to this. So there's the package. This is the 300 millimeter wafer. Each one of these little squares, in case you haven't seen one, is a possible chip. They don't all work. What fraction of them work is called the yield. And all the factories in the world are trying to maximize their yields to get more and more chips so they reduce their cost. And if you look within that, there's these, this is what the layout of the chip looks like, connections of lots of transistors together. This is what it looks like in a simulated layout. People like Synopsys make that happen, Cadence. And if you look within the piece of silicon, here's interconnects. It shows you one level of interconnect going this way, one level of interconnect going this way, and connecting the 2 layers of metal is called a, anybody know? It's called a via. I don't have the data for the latest Intel chips, but NVIDIA chips a few years ago used to have 7 billion vias per chip. 7 billion. If one of them didn't work, what happens? It goes in the trash can. What does that do to the finances for NVIDIA? Every time they lose a chip, it shows at the bottom line. Are you an engineer that's going to go make that happen so that they have some redundancy built in, maybe? New techniques to do that? Better process techniques to make that happen? Better circuit design techniques, better layout techniques, all kinds of innovation that is required. You can be playing into that. Now, when you're going to graduate school, you probably don't know where you could apply yourself. So fundamentally, get good at what you're doing, have an open mind. If you're going to go to an employer and say, I want to do analog circuit design, that's it, leave me alone, that's okay. You will probably have a career. But if you want to go do bigger, better, broader things, be open. Take on more things, take on more suggestions, and that's a career path that I certainly espouse, and I would recommend some more. So, why am I excited about this field? This device is not going away, right? It'll probably become more capable, maybe cheaper. I'll tell you my own story, right? I used to carry this laptop all the time, right, for the last 10 years. And then I started to use the phone. I never used to carry an iPad, but it's got a place in my backpack now. I used to up until maybe a year or so ago, until I got the iPhone 6S. And now I don't use it as much. Why? Because the iPhone is pretty powerful. The screen is maybe a tad bit smaller than the iPad mini. It is smaller than the iPad mini. but I can live with it. The resolution is good enough that I can live with it, and I almost never use the iPad anymore. So this is how transitions us as users are indicating, right? So if you now look at Apple sales of iPads are probably going down. So somebody, if you're in a management chain at Apple, you're looking at those projections and deciding, is this a product I want to do, continue to make, or is it going to get replaced with something else? So that's another dimension. You know, Apple has lots of people that are looking at product management. They're looking at people that understand customer needs. That are trying to help decide what product to build. And again, you can play any of those roles as an engineer. Figure out what you enjoy doing. I mean, I know what I would do. I'm more, you know, I've been around so long. I'm more in the breadth, the management and business side. In fact, what I tell people is, you know, in my consulting business, my clients, if they're looking for somebody to come do a layout of a chip, oh, you know, I can do it. I've done it before. But that's not why you hire me. You hire me for the trade-offs that people need to make at the senior level to help decide what's the right product to build, what's the cost effectiveness of that product, what's the customer demand. That's the value that I add. Okay? That's why I'm doing the talk today, and experts are doing the talks later on, because I wouldn't want to compete with them, right? That's not where my value add is. So again, I'm giving you that example because you've got to think about where your value add is. That's where you'll be the most successful. And by the way, your value add can change throughout your career. It can be technical to start with, and if you have the right perspective, you can broaden it if you want to, or you can stay technical. They're both entirely possible. Just decide for yourself what is it that you're good at and what you want to do. Okay, so let's get into the industry background and challenges. Any questions so far, by the way? Are you convinced that the world is changing? It's a different set of companies you want to go work at, and you can control your own career. You know, some of it, having said that, some of it really depends on the opportunities that come your way, and you got to be in the right place at the right time. We'll talk again in context of startups also, right? In startup, you could do all the right things, and some really make it to the top, and some don't. So that's more a matter of luck. But I think you can certainly take charge of your own careers. No questions? Remember, you got to get my signature at the end, right? You want the sign up. Okay. So background of the industry. Where we play in the semiconductor business is in a field that's electronics and systems. So if you go to any of the agencies that keep track of the whole industry, they will categorize us as systems people. The system could be the automobile, it could be computers, communications, industrial. There's standard categories that they go. Military is another one. So there's some standard categories. Systems industry is off the order of $30 trillion annually. That is supported by electronics, which is about $1.5 trillion. So what's the ratio? 20 to 1. They can't do without electronics, but they make 20 times as much money. Okay? The semiconductor industry today is more like $350 billion, but in this example it's at 300, so it's about 50 to 1. No, 5 to 1, right? 5 to 1. So for every dollar that the semiconductor industry ships into the electronics field, the electronics manufacturer makes 5 times as much money. And to continue the value chain here, materials and equipment is $80 billion, so it's 4 to 1. Where's the biggest leverage? 4 to 1, 5 to 1, 20 to 1. So now if you had a choice, where would you want to be? You want to be in the system. Now, that's the hardest to do, right? Because you're competing against Mercedes and BMW and all of those things. But give you an idea, fundamentally, the higher up the value chain that you go, the more opportunity for revenue. Keep that in mind. Because when we talk about entrepreneurship, you will have a choice. Do you want to build a chip? Do you want to build a packaged part? Do you want to build a box? Or do you want to build a whole system? How you decide that, there's a lot of factors, right? It's opportunity, it's your core competency, what kind of team you can put together, all of those things together. I will cover this a little later, but let me give you an example. How many of you have a USB-C device on your laptops? You got a new Intel or Apple-based computer? No? USB-C is a new standard. You got one over there. So there's a new standard, right, for connections. It's very different than the old, you can't just use the old cables. You can use this for power charging. You can use it for data communication. All in one. You can flip this upside down. So if power was on one side and you flipped it, what would happen? It would burn your computer or burn the cable, right?